Alright, hello. We have a horrible looking integral here. So we'll start by using some of the log laws to separate out the numerator and the denominator, well the power of the denominator. So this can be rewritten as the integral of log of x minus log of pi. Log of pi is just a constant, so that can be quite nice. Over then the log of x to the power of log of pi times log of e. Log of pi plus log of e. Remember, log of e is just 1, so we'll put that in there instead. All still integrated with respect to x. Now then, we'll use a u sub, and we'll have u is equal to log x. So we know x is equal to e to the u. And when we differentiate, we'll get that dx is equal to e to the u du. So we'll stick that all inside. Our integral is going to be the integral of log of x is now just u, minus log of pi, that's just a constant, so that stays the same, over log of x, which is u, to the power of log of pi, just a constant, plus 1. And we'll have a eu du. Spot on. Now we'll take this fraction and we'll split it up into two fractions. So where we have u over u to the log pi plus 1, this plus 1 and this u will cancel off. So all we've got there is going to be still the eu on the end, multiplied by u to the minus log pi. And this bit over here, this is just a constant, this is e to the u, and the bottom then will still be the same. So over there, we're going to have take away from the takeaway on the top, log of pi, e to the u, and then u to the minus log pi minus 1. All still integrated with respect to u. So now then, I'm going to split this into two integrals just by putting the integral sign in there, which is completely fine to do. We've got constants out the front. All of these bits still need to be integrated with respect to u. So now then, we're going to focus on this first integral. We'll have the bit to differentiate as u to the minus log of pi. So when we differentiate it, the minus log pi will come to the front. We'll still have a u, and we'll drop that power from log of pi, minus log of pi to minus log of pi minus 1. The bit to integrate, we'll have as e to the u. When we integrate that, we'll get e to the u. So we can stick this all together. This integral will just come with us for a sec. We're not going to do anything with that. So our original integral is equal to u times v, e to the u multiplied by u to the minus log pi, and then minus the integral of u dash v. So the minus and the minus will make a plus. There's a log pi as a constant, we'll stick that out the front. And then the integral of e to the u multiplied by u to the minus log pi minus 1 du. And now we need to bring this bit with us as well. So we'll have a minus log pi integral of e to the u to the minus log pi minus 1 du. And what we can spot now, these two integrals are the same. We've got log pi and log pi, e to the u, and then u to the minus log pi minus 1, u to the minus log pi minus 1. This is a plus, this is a minus. So these two integrals are the same, so they're going to cancel off with each other. And all we're left with then is e to the u to the power of minus log pi. We'll take this up here to the right. We'll have e to the u and u to the minus log pi, and we'll replace our u with log of x and our eu with x. So what we're going to have is equal to x multiplied by u, which is log of x to the power of minus log pi, and we'll just stick that log of x on the bottom. So we have x over log of x to the power of log pi. We can have a plus c as well, but it doesn't matter when it's MIT. So spot on, lovely jubbly.